This is section 14.11, and the subject of today's section is analysis of the M+2 peak. So to start with, we're going to have a look at benzene because it has a very nice M+1 peak. Benzene has its molecular ion and base peak in the same place at 78. And we remember from section 14.10 that it has an M+1 peak that is equal to around 6% of of the base peak's abundance at 79, which is what we see here. But the subject of this section is M+2 peaks. So the question is, how does that arise? M+2 peaks come from, again, isotopes. For instance, chlorine can impart a strong M+2 peak character to a mass spectrum. Take, for instance, this chlorobenzene that's shown in your book, and you can see that there are two peaks now in that base peak, or in the molecular ion peak area. There's a larger peak that is the base peak at 112, and this is the molecular ion of M. But also there is an M+1 and M+2 peak, and in addition to an M+3 peak there. So the reason why there's an M and an M+2 peak is because chlorine has two major isotopes, one that is chlorine-37 and one that is chlorine-35. And typically, you see a pattern where the M peak is about twice as high or 3 times as high as the M+2 peak, because chlorine's two isomers are in 75% abundance for 35 and 25% abundance for 37. So the first one will always be twice as high, twice as high, at least 3 times as high, 3 times as high as the M+2 peak. It's worth noting that there's also an M+1 peak because of the natural abundance of carbon, which is carbon-13, and as well an M+3 peak, which comes from the very small chance that there is a natural C14 or C13 present at the same time that there is the chlorine-37 present. Another atom that can give M+2 peaks is bromine. And the reason why bromine does this is, again, because of its isotopes. It has two isotopes, bromine-79 and bromine-81. And these are almost exactly naturally abundant. So the two peaks are typically very close in the relative abundance in the spectrum. So here in bromobenzene's mass spectrum, you can see there's a base peak at 78, but also there's a molecular ion peak at, I can't really tell what that is, maybe 158 or something like that. And then another peak at 160. The 158 peak is M, and 160 is the M+2. And we see the same M+1 and M+3 peaks that come from carbon's isotopes. And so using the M+1 and the M+2 peaks can give us a lot of information about what atoms make up a molecule, and that is just from the mass spectrum. This has been section 14.11.